Have you ever had a craving for pizza but found yourself lacking the time or ingredients to make it yourself? Just like outsourcing the responsibility of baking a pizza to a delivery service, Dependency Injection allows us to outsource the responsibility of instantiating an object to a Dependency Injection framework. This way, we can simply call the framework and inject the required object in the place where we need it without the tight coupling of knowing how to create the object in multiple places of our codebase. Koin is one such dependency injection framework that takes care of the instantiation process for us. With Koin, we can focus on enjoying our app's pizza without worrying about the ingredients or how they are prepared. In this video, we'll see how Koin can be used in a Kotlin Multiplatform project with Compose Multiplatform. Hi guys, my name is Yannick Reis, I hope you're doing well and I welcome you to a new video. Dependency injection is probably one of the most popular design principles in the modern software development world, and therefore also very relevant when it comes to developing a mobile app with Kotlin Multiplatform. By using dependency injection, just like we are no longer dependent on the baking process of a pizza and all the required ingredients, we can receive or inject any pizza from our delivery service to our house door. We don't care about its baking process, so whether it's just warmed up in the microwave or actually baked from a pizza chef. Let's even go a step further. Let's say we are that hungry that we don't even care if it's a pizza or a hot dog. The provided food just has to be eatable. That way, we can rely on the abstraction of food and its solely purpose of being eatable. Just like from a software object, which we expect certain functionalities without actually caring about its implementation logic, as long as it fulfills the contract of a specific type, like an interface. Staying in the software world, the design principle of dependency injection allows us to develop testable code by simply swapping out the actual implementation we use for our runnable app code with a testable implementation or a mocked version when writing our unit tests. But not only the testability improves, our code will automatically be way more maintainable when instantiation of our dependencies happens in a single place of our codebase. And an object no longer needs to change just because a small part in the instantiation logic of a dependency changes. Koin is a dependency injection framework that can act as our pizza delivery service. It is Kotlin Multiplatform and Compose Multiplatform compatible, very easy to set up, and provides a very simple API in form of a Kotlin DSL that allows us to declare any implementation logic for types that can then be injected as dependencies in almost any place of our codebase. But that's not all. If you don't like manually declaring your types, you can even use Koin's own KSP plugin to automatically generate those definitions via annotations. We start with how to set up Koin for your Kotlin Multiplatform project with Compose Multiplatform. We will see how we can define our types that we want to inject manually via Kotlin DSL, and afterward how to do the same with the KSP plugin and how to inject classes not only in regular Kotlin but also our Compose code. So let's talk no further and get right into it. So before we start, make sure that you check out the Compose Multiplatform Android and iOS template project, just like we saw it in the previous videos. Additionally, I checked in the GitHub project I used in this tutorial video here, so you can also look up some dependencies and so on there. So no need of manually writing all the stuff, just copy it and you're good to go. So the first thing we need to do when introducing Koin in a new Kotlin Multiplatform project is to add the required dependencies. And because we're in a Compose Multiplatform project, most of the part will happen in the common main module. So here in Android Studio, make sure that you go to the build Gradle KTS file of your shared module. Let's scroll down and here you can see we added some Koin dependencies. So the first one is the Koin BOM or bill of materials. Inside this bill of materials, there are compatible versions declared. So if you add another Koin artifact here, because there are already like 10 or 12 artifacts, it will select the respective compatible version. Whenever you need to overwrite that, you can simply add your respective alpha version or whatever here. Afterward, let's go into the Android app module, and here in the build creator file, we also add the same Koin BOM, but this time not with the Koin Compose dependency, but with Koin Android. For the raw Koin DSL usage, that's already it for setting up our KMP project. Next, let's see how Koin works in practice. So how can we actually declare a dependency? Let's start by declaring a new folder structure here. So let's say we call it Kotlin tutorial.shared, and let's put in our code here, make it a little bit bigger. Let's start by declaring two new classes, class A and class B. So and let's say class B depends on class A somehow. We can use two different approaches here. One is field injection and the other constructor injection. Let's quickly see how we can use field injection. So to do that, here in class B, we need to implement the Koin component. And now let's say we have a field here that is called class A. And now to inject it, we simply say here inject, and this inject comes now from the Koin component. And as a type, we say we want to have class A. And that is already it for the field injection. But what is the problem here with this approach? In this case, it's not that easy to override this dependency or this implementation with a mocked implementation or a test implementation for a unit test. So the better approach is to use the constructor injection. So we can instead simply define the class A here in the constructor. Now we can also again remove the Koin component and are done at this point. But how does Koin now know how to provide the class A for class B? And finally, how to provide class B somewhere when we want to inject it in our real code base? For that, Koin used a concept called modules. In those modules, we define our type definitions, and Koin will do the rest for us. Let's first create a new file and we call it shared module. And here we simply declare a new variable. Let's say share module, and then we can use here Kotlin DSL from Koin. Now inside this scope here, we can define our types. So in our case, we want to have a class A and a class B. Let's start by declaring class A as a singleton. So whenever it gets called, the same instance should be returned. For that, we can use the single keyword. So here, because class A has no further dependencies, we can simply instantiate it via the constructor call here. When for the first time this class A will be required, it will be instantiated and provided to the respective classes. When another class requires this dependency again, the cache will return the same instance we had before. This happens only at the first time it will be called. How can we, for example, create it from the app start? For that, we can provide here a parameter created at start should be true. So now, if we start our app with Koin, a single instance will be created for class A. Okay, great. Now we have our definition for class A. Let's proceed with class B. Class B should always create a new instance. So for that case, we can use the factory keyword. And if we now say here class B, we can, or we need to provide the respective dependency for class A. How can we do that? For class A, we can simply say get. And get also comes from Koin. When the dependency will be resolved at runtime, it will automatically see class A is required, and because it's the only instance here that is available, it will simply provide class A. Okay, that was a simple example, but let's say we have two additional classes. So there's also a class C, and we have also an interface, which is sample interface. Now class A implements this sample interface as well as class C. And now class B should no longer depend on class A, but on sample interface. So if we now go back here to the shared module, we also need to provide a type for class C. So now also both of these dependencies here should be for the sample interface. And now you might already see the problem here. We have two definitions that both provide the sample interface. Which of those should Koin take at this point? For that, we can use a so-called qualifier. And let's say that we want here a qualifier, and we can also provide here an enum. But for this case, let's say we want simply a name and it's ABC. When providing the definition here for, let's say, class C, we can also provide such a qualifier. By doing that, Koin will at runtime know which of those types it should provide. Okay, that was quite okay to define, I would say. But Koin also provides other methods for defining those definitions. Let's see how Constructor DSL, for example, works. For this class C definition here, we now say instead sample interface once again, and then we define the class C here in this lambda. And because we also want to provide some options, we can simply say with options and have another lambda in which we now can say created at start and also named. And this named now also contains a label. So once again, ABC, and we can remove the previous declaration. As you probably know it, in the course of developing a mobile app, those definitions change quite often. So instead of hardwired declaring those things here, we can also use another approach. And let's say instead of declaring here the class A in that way, and maybe in the future, there also will be some more dependencies that we need to provide in the constructor, we can instead say single off. And now we just need to provide a function reference to the constructor of class A. So let's say here class A. And as you can see, we are already done. What if we would need to have here, just as an example, ASD as a parameter? If we go back, you can see that we need to provide a string here. But in the single off, we don't. How is that? That is because single off has multiple overloads of up to, let's see, 22 parameters we can provide in the constructor without having to touch this declaration here. So as you can see, there are multiple ways with Kotlin DSL alone how you can declare those definitions. And if we also want to have here created at start, we can simply once again say here in the lambda block created at start and would achieve the same as the sample above here. So let's also remove that. Now that we saw how to declare those modules, let's see how we can actually use Koin in our application. So now that we saw the module approach, how to define our dependencies or definitions, how can we actually use them in our app code? For that, we first need to start up Koin at the point of app initialization. And in that point, we also need to provide all the modules we need for our app. For Android, that's quite easy because we can make use of the native toolset. So let's quickly see how that works. For the Android part, that's quite easy. As we earlier did, we introduced some dependencies in the Android module, and now we can also access them. So the first thing we need to do is to create a new application and implement the Android application here. Then go to your Android manifest and also declare the application here in the application block, so it will be used instead of the default one. As you can see, we have here the Start Koin. We provide an Android context, so you can also use injection of the Android context if you have some specific Android classes. We use here the Android logger to log some KSP stuff, and then we need to provide our modules. And we can simply do that by saying here modules. And you can see there are 3 overloads, but because we only have one, we can simply say here shared module. And for the Android part, that's already it to use Koin in your app. For iOS, however, we have no native toolset to start Koin, but we can use the concept of Kotlin Multiplatform. So let's go into the iOS main module here, and inside that we define a new function and say init Koin. And here, because we are in the shared module, we can now also use the dependency we declared for the common main module, and that is now also Start Koin. And let's here simply say modules once again, share, and I realized it should be shared, not share. And now we're also fine for the KMP part. And now we also need to call this part here when starting up the iOS app. So for that, let's go into the iOS app folder, iOS app, and then inside the iOS app Swift file. So if we now switch to the iOS project in Xcode, also initialize Koin here. So we can do that by first importing here the shared module, and then we say here init, and then we can access the main iOS KT, which is the shared file we earlier provided. And then let's say do init Koin. And by that, let's quickly try out if the app start up. Oh, and as we see, the app crashes. But why is that? Because we earlier defined the string in the class A here, but because there is no respective definition that Koin can use, and we also set Start Koin at the initialization of the app simply crashes. So that is one drawback with the raw Kotlin DSL, because you don't know at compile time if all required dependencies are provided. We now remove this parameter here and then go back to the Xcode project. And now we rerun the whole thing. You can see that the app starts up, and we also have our hello Koin here. Okay, now we saw how we can use Koin DSL for declaring our definitions, but how to do the same using the Koin KSP compiler I earlier talked about. For that, let's go back to the build Gradle file to introduce some new dependencies. Because the plugin is a KSP plugin, we also need to enable KSP for our KMP project. First, let's go into the Gradle properties file. And here add a new dependency. If you are also on Kotlin 1.9.21, then you can also use this version or a newer one. And next go to the settings.gradle.kts. And here introduce the KSP version for the project by declaring here an ID, com.google.devtools.ksp, and set the respective version. So everywhere in our project we use the KSP plugin, the same version will be used. Then the first thing we want to introduce this KSP plugin is once again our shared module. And here you can simply use the ID now, because we earlier provided the respective version in the settings.gradle file, it will use the correct version. Then go down to the source sets, and here we want to provide a source directory to tell the common main module where it can find the generated files. So in this case, KSP metadata common main Kotlin. And then we go further down to the dependency section once again, and make sure that you introduce this dependency here, so that in our shared code we can also use the annotations from the Koin annotations artifact. Then it gets a little bit trickier. Now create a new dependencies block and use the following statement here. You don't need to write all the stuff by yourself. I also got it from the Insert Koin IO Hello KMP sample project from Koin. So you can either copy it from there or use my GitHub repository I put down in the YouTube description. And by using those Gradle tasks here or configurations, we make sure that the KSP process first compiles and then the actual Kotlin compile process. After that cryptic part, also go to the Android module once again. And here inside the build Gradle KTS, we also need to provide the Koin annotations implementation, and then with the KSP keyword, also the Koin KSP compiler. And also don't miss to add the KSP plugin to the plugin section here. Once again, you don't need to follow it, just copy it from the GitHub repository. Okay, now that we have that in place, let's see how we can use annotations instead of manually declaring our definitions. For that, let's go back to our shared module. Now in this shared module, let's say we no longer want to declare all these things manually, but do the same with annotations. So for class A, we want it to be a singleton. So we go to class A and simply say here, add single. Next for the class C, it's the same. And we also said that class C has this qualifier, and the equivalent is here just to say add named. Again, it's ABC. And the same also goes for class B. So here we also want to have factory. And now we can simply say here in front of this parameter named ABC. And now if we build our app, the default behavior will be that all annotated classes will belong to a so-called default module. Because in general, it's a good practice to have encapsulated modules. Let's also, once again, reuse our shared module here. But instead of this declaration, let's slightly adapt it. Class called shared module. And here we add an annotation which says module. And we also say here component scan. So if you would like, you could also provide here a specific package which this module should get its components from. In this case, we say use all of those packages here. You can optimize this, quickly rebuild. And now you can already see that we have some problems here because, of course, the variable is now gone. So we can replace it with shared module, and then we call here .module, which is an extension function from the generated code. So the same goes for the iOS part or the multi-platform part here. So we also place it with shared module .module. So fix this import. And now if we rerun the Android app, as you can see, everything works as expected. Okay, great. Now we saw how we can use the manual declaration, the annotation-based declaration, but how to use those dependencies actually in our Compose code. Because at the end, we're here because of our Compose Multiplatform project. So let's say we have here our class B. This class should also do something. So calculate something, maybe 2 by 3. And now let's see how we can use that in our Compose code. So go to the app.kt file, and to use this class B now in our code, let's do a quick refactoring. So we put this into app content, and now once again need to have the composable notation. And what we need to now to do is that we need to take the Koin context we started from Android and iOS and use for our Compose code. So we can simply say Koin context, and inside of that we launch our or put in our app content composable here. And now let's use the class B here. So we say simply class B, type is also class B, and then we can say Koin inject. And the only thing this composable function here does is to resolve our respective dependency. So in our case, this class B from our Koin context. So let's quickly use here a column instead. Let me say here fill max width. We add a small text, sample text, and then let's say here sample text equals remember, and for one time the first composition we call it calculate something, cast it to a string, and let's say I don't know, we also say result, and let's simply show here the text. Of course, that should then be sample text. And let's quickly also adapt that here. And now let's start the app. Okay, great. Let's click on the button. And as you can see, we have result 6 here. So without knowing how this actually is implemented, we can just say here Koin inject, and we receive our dependency, and we can simply call it. And by that, you should have a brief overview of the Koin dependency injection framework with a KMP project and Compose Multiplatform. Of course, there are also other options and functionalities that Koin provides, but I think by now you should be able to implement dependency injection framework into your own project. Are there also other dependency injection frameworks you already heard about that are multi-platform compatible? If so, let me know in the comments. I hope you had some takeaways. Like the video, subscribe to my YouTube channel, activate the notification bell, and I hope to see you soon.